All right, here we're going to be looking at comparing linear and nonlinear functions. And again, it's something we've kind of looked at in the past with equations and knowing the difference between the two. So it should again just be a little review for us. First of all, I want to look at the difference between the words linear and nonlinear. If you think, or if you just look at the word linear, you see the word line within that. So anything that's linear is going to be a straight line. So if you just keep that in mind as we go through this, make things a lot simpler. So the first thing we're going to look at is identifying functions from tables. So whenever you have a table, what you want to look for is if it has a constant rate of change. Same pattern basically going on each time. So if it does, it's going to be linear. If there's no constant pattern, no constant rate of change, it's going to be nonlinear. So here we have an XY table. And if you noticed, your X values are 3, 6, 9, and 12. So those are increasing by 3 each time. And then if you look at your Y values, we have 40, 32, 24, and 16. And you should notice that these are decreasing by 8 each time. So we have a distinct pattern with the X's and a distinct pattern with the Y's. So this table shows a linear function, looking for that constant pattern or that constant rate of change going on. Now, if we look at the next one, just simply asking, is this linear or nonlinear? Okay, so we have another XY table. Our X values are 1, 3, 5, 7. Our Y values are 2, 11, 33, and 88. So it's easy to see the pattern with my X values. You're just adding 2 each time. But what I want to look for is there a constant rate of change with the Y values? Well, to get from 2 to 11, we add 9. 11 to 33, we add 22. 33 to 88, we add 55. So there is no constant pattern going on in this table. So we would say this is nonlinear because there is no constant rate of change with the Y values. Okay, so that's looking at it from a table perspective. You're looking for a pattern or a what's called a rate of change. Now we're going to switch gears and we're going to look at identifying functions from a graph. And this is probably the easiest part of this. What you're going to look for, we kind of already talked about this, but it's going to be linear if it's a straight line, and if it's not a straight line, it's going to be nonlinear. Okay, so go ahead and just sketch these two graphs. They don't have to be perfect, but just get them sketched down on your paper and just simply want to know, is it linear or is it nonlinear? So on this first graph, okay, looking to see if it's a straight line or not, and it's curved. So this first one would be nonlinear. And then the second one, we got just a straight horizontal line, so that would be linear. Now, one type of graph that you may see that may confuse you is something that would look something like this, where those are two straight lines, but because it's bent, it is not linear. You're wanting one straight continuous line for it to be linear. Okay, the last part of this that we're going to look at is identifying a function from an equation. So just given an equation, how do you know if it's going to be linear or not without graphing it, without making a table, any of that, just looking at the equation? So what you want to look for if it's linear is if the equation just has a plain x in it. There's no exponent with it, and it's not the denominator of a fraction. So if you look at your equation and the x is just plain with no exponent, it's going to be linear. It's nonlinear if the x has an exponent, x squared, x cubed, x to the fourth, any of that, or if x is the denominator of a fraction. So if you have like 1 over x or 6 over x, something like that, that would be nonlinear. So we have 4 examples here, and we're just going to say if they are linear or not. So number 1, y equals 4.7. Well, this one doesn't even have an x to even worry about. So this one would be linear. And based on what we've talked about in the past, is that would be a, since it says y equals, would be a horizontal line through 4.7. Number 2, y equals pi times x. Again, I'm focusing on the x. There's no exponent, and it's not the denominator of a fraction, so this would be linear as well. Number 3, y equals 4 over x. Now, the x does not have an exponent, but it is the denominator of a fraction, the bottom number in a fraction. So because of that, this one is nonlinear. And then number 4, we have y equals 4 times the quantity of x minus 1. Okay, now looking at it like it is, the x doesn't have an exponent. We could also rewrite this, use the distributive property, rewrite it as y equals 4x minus 4. But even still, the x does not have an exponent, and it's not the denominator of a fraction. So this equation would be linear as well. So again, this was just a review of things that we have done in the past, but now looking at the function rules and the equations that go with them and knowing if they are linear or nonlinear.